my name is Alia. Okay, for our case study, we choose the Selangor Maritime Gateway, also known as a Royal City of Klang development. It is a large-scale river rehabilitation and urban regeneration project carried out along a Klang River. The project covers about 56 kilometers stretching from Kuala Lumpur to Port Klang, with the main aim of restoring the river environmental quality while also improving the socio-economic potential of the surrounding area. This initiative was needed because rapid urbanization, industrial activity and uncontrolled waste discharge have caused major issues such as pollution and sedimentation. Over the time, this problem reduced the river hydraulic capacity, increased flood risk, and worsened overall water quality. So, SMG was planned a long-term integrated program that combines river rehabilitation, flood mitigation, riverbank stabilization, and waterfront development. From a construction perspective, it involved river works and canal engineering, such as dredging, slope protections, bank strengthening, and improving flow capacity, and then carry out in the stages to minimize disruption.
Hi, my name is Danish. Next, I will explain the key parties involved in the Selangor Maritime Gateway project. The Selangor State Government acts as the client and project owner, providing policy direction and approving the project scope and funding to meet environmental and flood objectives. Nada Salimaya Sdn Bhd is the master developer, coordinating implementation, managing project phasing, and integrating river rehabilitation with waterfront development. For approval and technical control, we have DID Malaysia is responsible for reviewing works such as dredging, riverbank stabilization, and flood mitigation to ensure hydraulic performance. DOE Malaysia monitor environmental compliance, including water quality control, sediment management, and pollution prevention measures. At the local level, Majlis Pembandaran Kelang (MPK) handles planning, approval, and permits. Finally, professional consultant prepare design, cost estimate, and method statement, while main contractor and specialist subcontractor execute the works such as dredging, sheet piles, geotextile installation, and heavy plant operations.
Next, I will explain the major components of our case study. Because the project is carried out in urban river corridor, the method selected must be durable, controllable, and practical in limited working space, especially near existing building, bridge, and utility. Okay, first is mechanical river dredging. This removes sediment, sludge, and solid waste to restore river depth and improve the flow capacity. It also supports flood risk reduction by improving circulation and reducing stagnant polluted area. The typical process include bathymetric survey to identify hotspot, controlled excavation using ponton, and proper transport and disposal with quality control on depth and turbidity. Second is riverbank protection using riprap and revetment. After the river channel is improved, the flow can create stronger erosive forces, so the riprap with a geotextile layer is used to prevent erosion and soil washout. The work involved slope refilling, placing and anchoring geotextile, and control road placement with correct sizing and toe protection. Third is the steel sheet pile retention system. This is suitable for narrow urban area because the pile can be driven vertically without wide excavation, helping to protect nearby structure and reduce land requirements. The steps include setting out alignment, driving the piles, installing wallers or strut if needed, sealing joint, backfilling, and considering corrosion protections. Number 4 is reinforced concrete retaining walls and flat walls. This provides strong structural support to the riverbank and act as flood barriers designed to resist hydraulic pressure where space required near vertical restraint. Construction usually include foundation or piling, formwork reinforcement, concreting and curing, and waterproofing with proper drainage for durability. Lastly, the project includes maintenance access and waterfront structure. This provides long-term access for inspection and cleaning, improving operation and maintenance, while also supporting public walkways and revitalization along the riverfront.
Hi, my name is Aisha and I will present the construction method of land reclamation. There are 6 main stages. The focus on site investigation, dredging operation, hydraulic field placement, riverbank protection, ground improvement, and surface treatment. So obviously, for any type of construction, of course, we need to start with an investigation of the site to know more about the type of soil, the condition of the river, and so on. The investigation include hydrographic survey, geotechnical investigation, and setting up reclamation boundary. This investigation is important for us to make a conclusion of what method that will be carried out for this project. Before we start with dredging, I mentioned that we had to set the reclamation boundary first. What that means? That means we build a retaining wall such as sheet pile that function are to keep the soil that we pump in from collapse. So imagine that we don't have a retaining wall, it's just a piece of land, and we keep the soil on top of it. Of course, it will collapse and spread. This will make our work hard and waste a lot of time and effort. Therefore, after we set the boundary, we can start our dredging operation. For this project, we use cutter suction dredging since it is a shallow water. The cutter head will rotate to use a compact sediment like sand and silt. The loose sediment then become kind of slurry form when it mixes with the water. The third step is hydraulic field placement, which is a pumping process. Those sediment from the dredging will be pumped through a pipeline into a reclamation area that we have prepared earlier. The soil will lay it with a heavy material first, such as rock, then the slurry material on top of it to fill the gap of the rock. This method helps the reclamation land become more even and sturdy. The next step is a riverbank protection works. This is to maintain the reclamation stability using a temporary or permanent structure such as sheet pile, gabion, rebattlement, which are built around the reclamation area. For this project, we use permanent structures since before the dredging, we already use a sheet pile. So this just to help prevent erosion and ensure the river can still carry float water safely. Next are ground improvement. This step is important since the soil placed by the cutter suction dredging is usually loose and contain a lot of water. So it needs to be strengthened before any construction on top of it can begin. So for this project, we use prefabricated vertical drains (PVD) to help water escape from the soil faster. So how PVD works? PVD are long and thin strips made of plastic or geotextile filter that are pushed into a wet soil across the site. When PVD being pushed, it creates a path for the water to move up quickly. At the same time, the soil has space to move closer. If a temporary layer of soil is placed on top of the ground, it will push the water out. It's just like a squeeze, so excess water escapes faster than it would naturally. And finally, after the ground has settled and stable, the surface will be treated with a topsoil or soil stabilizer or vegetation, depending on how the land will be used in the future.
Next is material used in this project. For riverbank protection and erosion control, the main materials include granite riprap, which act as a summer rock to resist erosion and scour. Under the riprap, a non-woven geotextile filter layer is placed to prevent soil washout and improve filtration separation. In some areas, gabion units or stone pitching are also used to stabilize slopes and reduce surface erosion. For riverbank retention and structural works, the project used steel sheet piles as a retaining system in narrow urban sections because they provide strong support with minimal excavation. Reinforced concrete is used for retaining walls and flood wall to provide stability and flood protection, supported internally by reinforcement steel bars. For reclamation and earthwork, selected a field or sand field is used for land reclamation and placed in stages with compaction to control settlement. Granular backfill is used behind retaining structure for drainage and stability, and PVDs or prefabricated vertical drains are installed to speed up soil consolidation. Lastly, for treatment and environmental feature, The project used concrete or HDPE pipes for drainage and sewer conveyance, and also includes eco-based materials like floating wetlands or bioretention media to support water quality improvement.
There are various types of plant and machinery were used to support river rehabilitation, dredging and flood mitigation work. So first, earthwork and excavation equipment was used for riverbank and land preparation work. Excavator were used for riverbank excavation, slope trimming and sediment removal. Backhoe loader handled a small-scale excavation in a confined riverbank area, while bulldozer were used for a land clearing and levelling near the riverbank. Tipper lorries and dump trucks transport soil, construction material and debris away from the site. Next, dredging and sediment removal equipment play a crucial role in restoring river depth. Cutter suction dredger were used for riverbed deepening and removal of sediment and rock. Trailing suction hopper dredger were applied for shallow channel dredging and transporting the dredged material. Ambiguous excavation allow work to be carried out in a marshy and waterlogged area. This machine help to improve water flow, enhance water quality and reduce flood risk. For river cleaning, the debris handling passive debris removal systems such as booms and barriers were installed to trap the floating waste. Floating skimmer and trash collector boat were used for active waste collection. Work barges and pontoons support the development of equipment. Under the SMG project, log boom were successfully constructed and a large volume of debris were removed from the river. Next, heavy excavation and earthwork machinery support overall river improvement works. Standard and track excavator were used for riverbank setting and sediment removal. Bulldozer assist with site clearing, embankment construction and access road formation. Backhoe loader and track-like excavation were used for digging and material loading. This machine support flood mitigation effort and improve the river capacity. For compaction, grading and stabilization, vibratory roll and compactor were used to strengthen the soil and reduce settlement after excavation and dredging work. Grader also were applied to level the surface and correct the slope. This process ensure a long-term stability of riverbank and access road. In terms of water management and dewatering, high-capacity pump and submersible pump were used to remove the water from the construction area. Coffer dam and ship pile were installed to isolate the work zone from the river. This measure create a dry and safe working condition, improve in construction quality and enhance the worker safety. For concrete and structural work, concrete mixture truck and concrete pump were used to construct the riverbank protection structure. Concrete vibrator and formwork ensure a proper concrete placement and completion. Retaining wall and embankment reinforcement were also built to improve the durability and provide the flood protection. Finally, surveying and support equipment play an important role in ensuring accuracy, continuity of work. Total of station and GPS equipment were used for alignment check, deep monitoring and quality control. Generator set supply power at remote site, allowing construction activity to continue safely and efficiently. During the Sungai Kelang Rehabilitation Project, several major challenges were encountered. First, solid waste accumulation, a significant issue. Large amount of rubbish such as tires, furniture, plastic waste were found along the riverbed. In fact, almost 40% of dredging materials was a solid waste. This made dredging work more difficult, slow down the river widening and deepening activity, also reduced the overall project efficiency. Second challenge, the discovery of human remains during the dredging and flood control work create a serious social and emotional challenge. More than 10 bodies, including an infant, were found. This led to a temporary work stoppage cause a distress among the worker and attract public and media attention. This situation requires a sensitive handling to respect the ethical and social concerns while ensuring the project could continue safely. The third challenges, coordination and governance issue. It affects the project implementation. The project involves several local councils including Kelang, Shah Alam and Petaling Jaya. Different in jurisdiction, inconsistent policy and weak communication between agencies make planning and execution more complicated. This highlights the need for better coordination and clearer governance structure in a large-scale project. Finally, public concern over transparency also poses as a challenge. The project faces a scrutiny related to the government, procurement process and political influence. Allegations regarding land matters, financing and leadership has raised a legal and political attention. This issue emphasizes the importance of accountability, transparency and clear communication with the public in the infrastructure development project. To address the challenges faced, several effective solutions and measures were implemented. First, river cleanup and engineering intervention were carried out together to improve the river condition. This includes the use of floating debris booth and solar power interceptor system to trap the waste before it spread downstream. Regular riverbed excavation, channel widening, river reprofiling and riverbank stabilization were also conducted. As a result, water flow improved, debris accumulation was reduced and overall river condition became better. Second, the management of human remains and public sensitivity was handled carefully and responsibly. Any human remains discovered during the dredging work were reported to the police and managed to according legal procedure. Transparent communication and regular update to the public help to reduce the community concern and allow rehabilitation work to continue with a minimal disruption. The third one, community program and local council action play an important role in ensuring a long-term river sustainability. Wastewater facility, recycling initiative, and public awareness campaign were introduced. Programs such as the Love Sungai Kelang Action Plan encourage public participation by reducing the plastic pollution and help to improve the river ecosystem. And lastly, multi-agency cooperation and transparency was strengthened through the project. Collaboration between government agency, local council, NGO, private partner improved the coordination and governance. Public engagement programs like Love Our River and Day Without Plastic has increased the community involvement and built a public trust in the river rehabilitation process. The Selangor Maritime Gateway Kelang River Rehabilitation Project showcase and integrate a sustainable approach to urban river engineering. It combines the dredging, riverbank stabilization, flood mitigation and environmental management to balance the technical efficiency, ecological resilience and socio-economic benefit. Challenges such as sustainable build-up, public sensitivity and stakeholder coordination were addressed throughout adaptive engineering, community engagement and multi-agency cooperation. Overall, the project served as a model for sustainable rehabilitation, offering valuable lessons for future urban river projects in Malaysia and beyond.